Equations can be written in word form, like you can see here, where it's got change in speed over time taken. We can shorten that down using symbols, and it becomes A equals V minus U over T. You'll see the list of the quantities and symbols. So A is acceleration, U is the initial speed of the object, so what was the speed at the start, measured in meters per second. V is the final speed, telling us what's the speed at the end, also measured in meters per second. And T is the time that change in speed lasts for, measured in seconds. So, to do these problems, use the same method that you've been practicing in class. We first have to list the information that we're given down the left-hand side. So for this example here, we've got a car starting from rest. It reaches a speed of 15 meters per second in a time of 30 seconds. And we have to calculate the acceleration of the car. So the first thing that I can write down is we're trying to find what A is. So A equals question mark. I then want to list the other information that I've got from this example. So it says that it starts from rest, and rest just means it's not moving, so its speed would be 0 meters per second. This would be the initial speed U. So I can write down U equals 0 meters per second. And remember, you can write meters per second as m/s, or you could write down ms minus 1. Keep reading. It says it starts from rest and reaches a speed of 15 meters per second. So that would be my final speed, which gets the symbol V. So I can put 15 m/s, or if you want, ms minus 1. The final piece of information is 30 seconds, which is the time. So I write that down as t equals 30 s. If we go back to the top, the equation I'm using here, put that in a different colour, is A equals V minus U over T. So that goes down here. After I've written the equation, I can then substitute in the values. So A doesn't have a number yet, so that just stays as A. And I then want to be really careful that I put the numbers in the right place here. So V is the 15, which goes in at the top first. I want to take it away from U, which is 0. So 15 take away 0, then gets divided by my time, which was 30. If I then do 15 take away 0, that just gives me 15. Divide that by 30. And my final answer becomes 0.5 meters per second. I can write it down as m/s squared, so that it matches the top part there. And basically what this tells us is that acceleration is how much our speed, which is in meters per second, how much that changes every second. So if we look at the second example, I want to do the same again by making the list down the left hand side. We've got a sprinter in a race, crossed the finishing line with a speed of 14 meters per second. If the sprint time was 16 seconds. We want to find what the acceleration is. So again, A is question mark. It says she crosses the finishing line with a speed of 14 meters per second. So 14 is going to be our final speed, which was V. We're going to assume that if it's a sprint race, that all the sprinters will start from rest, which means that the initial speed U would be 0. And we've then got time is 16 seconds. Now that I've made my list, I'm going to write the equation again, same way as before. A equals V minus U over T. A is question mark again, so that stays as A. Final speed was 14, so that goes in first, minus the initial speed, which was 0. And then I'm going to divide that by the 16 seconds. I can simplify that to just 14 over 16. And that gives me a final answer of 0.875 meters per second squared. And what that tells us is, obviously in a sprint race, your speed would increase from the start because you go from not moving to reaching a fairly high speed. And what it means is 0.875 meters per second squared basically tells us that her speed increases by 0.875 meters per second every second. And that's basically what acceleration is. It's how much does your speed increase by every second if you're going from a low speed to a high speed over a certain time. Final example. We've got a train travelling at 18 meters per second. It then took 12 seconds to stop from the moment the brakes were applied, and we want to find the deceleration of the train. Now what you're going to notice this time is, because it's a deceleration, it's not going to be like the sprinter in the last question where our speed increases, because it's the opposite. The speed is decreasing, so that means we get deceleration. And because it's a decrease in speed, we're not increasing our speed by a certain number every second. We're doing the opposite. We're decreasing our speed by a certain number of meters per second every second. So this time, right from the start, because it's deceleration, we're still finding out what A is, but this time it's going to be a negative answer, because it's a decrease of speed every second. So A will be negative. So make my list again. Ignore that number 1 on the page. So A is going to be question mark, because that's what we're trying to figure out. It says the train had been travelling at 18 meters per second. So it had been going at 18 meters per second. That means that value is going to be our initial speed of U. And that goes in there. It takes 12 seconds. So 12 seconds is our time to stop. Now if it stops, it's at the end of the journey and it's not moving. That's going to be our final speed v, which will be 0 meters per second. So, even though it's deceleration, the equation stays the same. A equals v minus u over t. Again, A we don't know. Even although it's deceleration, it still has the same symbol, which is A. And that's because we're giving this a negative in front of the final answer to show that the speed is decreasing. Now this is where we need to be careful with our list again, because v this time you'll see is 0, because the final speed is when the train stops. This train was travelling at 18 meters per second, so that goes in place of u. And our time at the bottom is 12. Now you'll see this time that when I simplify it, 0 minus 18 gives me a negative number at the top. Negative 18 gets divided by 12. If I do negative 18 divided by 12, I should get a final answer, which is negative 1.5 meters per second squared. What that means is the train decreases in speed by 1.5 meters per second every second. So when we've got deceleration, we've got a decrease in speed by a certain number of meters per second every second.